Vibes here, and today I'll be doing this maths question. So let's take a look at it. So we have a sphere of fixed radius r, which is inscribed in a cone, okay? And we need to show that r squared equals to this thing. So, and then we need to find the volume. So, volume, okay, so let's try to show the first part. So we have this is the center axis of the cone, then you have this, and then you have A over here. Then you have A, right? Because it's the radius of the sphere. Then this is the bottom of the cone, R, and then this extends down as part of the cone, and then the entire thing is height H. Okay, so right now so then that means that this distance is H minus A, right? So what I'm talking about is the distance from this point to the center, the top of the cone, to the center of the sphere. So top of the cone to the center of the sphere is H minus A. Then we realize there's actually similar triangles. So this is this triangle over here is similar to this triangle over here, right? Yeah. So what this means is that okay, we need to show R is related to H and A. So okay, so first of all, the hypotenuse, like this, is equals to H squared plus R squared. Yeah, so then we take H minus A over A equals to H squared plus R squared over R, right? Yeah, and then now we have a problem because it doesn't look like the answer. Wait, actually no, it does look like it. So we square both sides. H squared minus 2AH plus A squared over A squared equals to H squared plus R squared over R squared. Okay, so let's see if we can, now we have R squared terms, we can try to make R squared the subject of the formula. So R squared H squared minus 2AH plus 2AH R squared, 2AH R squared plus R squared A squared equals to A squared H squared plus A squared R squared. So you realize that A squared R squared cancels. So then R squared H squared minus 2AH equals to A squared H squared. Then R squared equals to A squared H over H minus 2A. Yeah, and then we have shown the result. So now we need to find the volume in terms of A and H. Well, now we already have R in terms of A and H. So volume of a cone is 1 over 3 pi R squared, right, times H. Yeah, correct. Then we just need to substitute it in, so it'd be 1 over 3 pi A squared H over H minus 2A H. So there would just be H squared on the, so let me just erase this and put H squared here. So yeah, so then as H, let's just finish the question. As H varies, find the value of H that gives the minimum V. So we are varying H to get a new volume, to get a minimum volume. Then we did not do, the question says we do not need to verify that V is the minimum. So we just need to find the stationary point. So this is the volume already. So we differentiate V with respect to H. So yeah, so we differentiate, and that will be pi over 3 times A squared. Then there's a derivative of d over dh of H squared over H minus 2A equals to pi A squared over 3 chain rule, quotient rule, f prime g 2h H minus 2A minus g prime f, so h squared 1 over h minus 2a squared. So this is the quotient rule, and let's set, and so this, we simplify it. 2h squared minus h squared will give you h squared minus 4ah over h minus 2a squared. So dv over dh is this thing, and then if we set it to equal to 0, then we want the numerator to be 0, so h squared minus 4ah equals to 0, h minus 4a equals to 0, so h equals to 4a, or h equals to 0, but in the case where h equals to 0, you have a 0 volume, so I don't think we consider that. Yeah, so the answer should be h equals to 4a. So yeah, thank you. So I didn't mean to save it. Stop the video.